We're going to look at solving equations using complex numbers and then review complex numbers. For the most part, you want your calculator to be in the A plus BI mode. So if you hit mode, arrow down and arrow over to the A plus BI, hit enter on it. It'll work just fine in that mode always if you leave it there. Remember that I is equal to the square root of -1, so therefore I squared is -1. We're going to go ahead and solve this. If we solve this, we'd have to take the square root of both sides. Then we'd have to go ahead and simplify the square root of -16. Well, -16, you know, is a 16 times a -1. You know how to take the square root of your 16, and we can take the square root of -1. You can apply the square root to each one when it's multiplication on the inside. You know the square root of your 16 is 4. Square root of your -1, according to what we have up here for our definition, is I. So you really get 4i and -4i. Here we need to go ahead and just simplify these. So you're just adding. So you don't really need the parentheses. Combine your like terms, those that don't have i's and those that do have i's. Now we're going to go ahead and distribute through your negative sign here. Parentheses to begin with don't do anything, but you've got to distribute through the negative sign here. Collect your like terms. Now we're going to just FOIL this first terms, outer terms, inner terms, last terms. Now remember that I squared is -1, and this negative I comes from combining together our i's to the first power. Now that's just a -21 here at the end, so you can combine that with your -10. You get a -31 minus your I. Some of you may be tempted to just apply your 2 to each one of these and square each one, but you can't do that when there's a plus or minus. So you got to think about what does squaring mean. It means multiplying by itself, so you're going to have to FOIL that out. Multiply your first terms, outer terms, inner terms, last terms. -70i comes from here. Remember your I squared is a -1. So that 49 with your -1 becomes subtract 49. And so then we get -24 minus 70i. Here we have an I in the bottom. We don't like to leave i's in the bottom because remember I is the square root of -1, and we don't like to leave roots in the bottom. So we're going to multiply the top and the bottom by the conjugate of the bottom. And then all we're going to do is FOIL out the bottom. First terms, outer terms, inner terms, last terms. Your inner and outer drop. -1 is your I squared. So you get this on the bottom. So you get 13. Now all you have to do is FOIL out the top. First terms, outer terms, inner terms, last terms. These combine together to give you a 29i. Remember this is a -1 for your I squared. Combine together your 21 and your -10. Now if you wanted, you could go ahead and write that as two separate fractions of an 11 over 13 plus a 29i over 13. Either one would be fine. Now, the reason we were doing the conjugate here is, remember when we were looking back at chapter 1, when we had a root in the bottom but two terms, you would do the conjugate. So we were doing the same thing here because your I in the bottom was a root of -1. Same idea here. Multiply the top and bottom by the conjugate of the bottom. FOIL out the bottom. FOIL out the top. Combine like terms, remembering your I squareds are -1s. And so then we get a -5 minus 31i over 34. Now, just as a quick review here, you'll notice here that these dropped. These were the inner and outer. And these dropped, the inner and the outer. And that's what happens when you multiply conjugates together. Here's 1. Here's its conjugate. When you do the inner and the outer, you get one of them to be positive, one of them to be negative, so they undo each other. So keep that in mind when you're doing conjugates, so sometimes it can actually save you some work. Powers of I. I squared, you know, is just -1. I cubed is really just an I times an I squared, which gives you a I times a -1. So it's a negative I to the fourth is really an I squared times an I squared, or a -1 times a -1, which is a positive 1. I to the fifth is really an I, because it's an I to the fourth times an I. And then that pattern continues. So when do we have ones? Whenever your exponent is a multiple of 4. Here you have multiples of 4. So if your exponent's a multiple of 4, you get 1. When do you have your i's? Well, your i's occur whenever your exponents are 1 more than a multiple of 4. You notice a 1, a 5, and a 9 are all 1 more than a multiple of 4. So you get an I. Whenever you're basically even but not a multiple of 4, which is really 2 more than a multiple of 4, you always get your -1. If you happen to be 3 more than a multiple of 4, you get your -I. So we need to go ahead and work these out. Is that a multiple of 4? No. But 36 is, and that's 1 away, so it's 1 more than a multiple of 4, so it's an I. Here is 43 a multiple of 4? No. But 40 is, and so this is 3 more than that, so then it's a -I. Here 16, is that a multiple of 4? Yes, so your answer is just 1. Here you have 33, is that a multiple of 4? No, but it is 1 more than a multiple of 4, so your answer is I. So we need to simplify these. Well, here you need to first of all simplify your root. The square root of a negative means you're going to have an I, and then you also got to take the square root of your 25. Same idea over here. You're going to have an I because you have a negative inside of your root and the square root of 36. Now all you have to do is FOIL, just like what we were doing before. Combine your like terms here in the middle. Remembering your I squared here is a -1, so we ended up with a positive 30 at the end. Now, if I had said this, you guys would probably conclude that the box has to be your 12 and the oval has to be your 7. And so whenever you have two complex numbers that are equal to each other, the parts that have i's have to be equal. That would be, or the parts that don't have i's have to be equal. And then the parts in front of your i's have to be equal. But only what's in front of your i's has to be equal, not the, you're not including the i's. So you set the yellow equal to each other, and you get this, and so therefore you get x to be 4. Now you set the orange, the stuff in front of your i's equal, and you get this. So you can actually plug your 4 in, and then you can actually solve it for y, and you then end up getting y to be a -16. Well, here we're going to go ahead and set this equal to 0. Then we're going to factor it. It's really differences of squares. So differences of squares again for the purple. This is really differences of squares because this is differences of squares. This is differences of squares. So how do you come up with these numbers at the end? You take the square root of that number. And so this is really differences of squares. That's really differences of squares. This is really differences of squares. So how do you come up with what goes at the end? The square root of that, which factors into a +3 and a -3 there. So that factors in. You set each one of these equal to 0, and then you go ahead and simplify, and you get your 3 answers, or 4 answers.